All right, should see my screen. Okay, this is working group node life cycle September 29th, 2025. Are there any introductions, any people that would like to introduce themselves before we get started? Say hello. Okay. All right, start with let's go to the second item. So we have for today we've got two items we'll talk through. First is the document I shared about 2 weeks ago, a week and a half ago. So we'll talk through that, and then with the time we have left, I'll spend on Philippe's topic. Okay, this document. So we talked about this. I think it was 2 meetings ago. Um, where I had proposed the idea of thinking about conditions and kind of their effect in the overall life cycle and sort of the problem we're trying to solve. And I said I'd create a document and some diagrams. And so this is the results of that. And I think I want to preface this whole discussion and conversation with that. I think this is just an idea. I think we there's certainly a lot of this is subject to change. A lot of this was trying to capture the spirit of um, what is going to tie a lot of our efforts together that we're currently working on. We've got a few caps that we're thinking about. What are some of how can we tie some of these things together? And so I wanted to come up with a sort of like a theme, something that like when the core reviewers, the Kubernetes community are thinking about what this feature, this cap, what is it that is important about these features, and what is it that what should we take away? Why should we take this feature, and now why is it important? What's different about this approach? And I think part of it is this idea of the background that um, where the approach and like what we're looking to solve and across a bunch of different caps here is that some of the current life cycle, the life cycle of the core APIs that we're working on, like a node, that there's some improvement that can be made. And I think the approach that's different is that we're looking at using not just a an approach that the core APIs have all the state and they have controller managing them. We're sort of, I guess, thinking about it as like it would across all these caps where we have some state and then we have sort of a user controlled um, component or a controller, like a plugin that's sort of helping to orchestrate and define the state, which is sort of a little bit different than the current approach we see with like CRDs, where people are extending the API to their own, molding it in their own direction. This being sort of like we're molding core APIs to do different lifecycle things. Because we have to, like these core APIs, we need to lifecycle them and they're critical and they're in the critical path and we sort of need some tools to help us define a lifecycle. So the phrase I came up for this, or the title, I guess, which is of course subject to change if we want to do that, um, is called Specialized Lifecycle Management, and the acronym SLM is how we refer to it. And like I said, this is the idea that we want to have something change on the core APIs that can help us do orchestration, complex lifecycle management and transitions, and then have it integrate across all our different operators and controllers but again, users, controllers, and in addition to working cooperatively with, across those controllers and across different core Kubernetes controllers. I think that's like the key thing is the cooperation with all of these components. And I think what's interesting is like when you look at we've had a lot of good presentations. I think we're all thinking this, that we have a good idea here and we're all doing it in these different ways. And we really want all these things to cooperate together. And so that's kind of the spirit of this is about the cooperation of all of these things. All right, is there, I can stop there. Is there anything people would like to add to that, or, any comments people would like to make about that? Okay, no comments. Okay, we can move on then. So I really didn't have like I think people have looked at this document and left some feedback in here, and I'm happy to go through and answer questions about this and even talk through the comments about this stuff, and kind of what this idea is, and we can have some discussions. Um, so the first one, Philip, you added this. Define a set of goal of node states, node maintenance states to represent major phases of the node's life cycle. Yeah, that makes sense. I mean, I think so. I said conditions. I mean, I guess that's maybe too much into the design. And is that what you're getting at here? Maybe we need to be a little more vague about this.
Yeah, exactly. Like because we still are not in the stage of like designing the API. So like I think we still need to like define our requirements first and
Yeah,
like what we actually want to achieve. And then like the API is like an implementation detail that we have to figure out like down the road.
yeah, sounds good. Okay. All right, I resolved that. I think that makes sense. Okay. All right, let's continue on. I left this section here as like I think this is just a note for people that are who come to this document who are interested in like tracking all of the things that we're talking about here. Like these are the ideas above, the summary and the background and the goal. But I mean, I think what we're talking about with this topic of SLM is like it's going to cross a bunch of these caps. Like that's sort of like the thing that we want people to think about. Like that what we're doing here is a little bit different approach, and you're gonna see it tied through a bunch of these caps. So I was gonna keep them here and actively track those. Yes, go ahead, Philip. See your hand.
Yeah, I would stay on this topic a bit more longer, like
Okay.
to like just make it clear and like what the dependencies are. So like first things first, like the eviction request API actually doesn't involve like the node in any way. It's just that we would like to use it for example, declarative node maintenance, but it's involved in a pod lifecycle and not much in the node lifecycle, like at least at this stage. And yeah, and the declarative non-maintenance, like we still also like we have like designed an API in like some manner like that we like are suggesting a new API object for non-maintenance, but this is also still not set in stone. So like it doesn't mean there have to be a new API. It can be even like part of the node itself. Like it's also still like in this work in progress stage. But like if it were that way that we design a new API like that, then we like would be tracking like the node lifecycle, or at least part of the node lifecycle in the node maintenance and also in the node object. So I mean it might make sense to decouple these, but like we can also try to look at them differently or as a subset of one of another. Yeah, so I know like in the like presentations we had here, I also saw that, for example, in the node lifecycle, people would also like to track, for example, the provisioning stage, like when the node is getting ready to accept workloads. So like there are other like states that people might be interested in, and not just in like in the maintenance part.
Yeah, that makes sense. I guess what I was thinking here is that there will probably be like a state that will eventually tie to the eviction request. Like you said, we're draining pods here, like it's the pod life cycle. I think maybe the only thing I was trying to get at is that eventually in a diagram that we can show how it is. how these things are related. I think their life cycles are like independent in that you could obviously do an eviction request. I think you've written it that way with completely independent of doing node maintenance. But I think like tying, but there is also a world where we do node maintenance, that we're also going to be calling eviction requests and doing drains. So I wanted to see if we could capture a bunch of these things kind of together to see how they would look. So it's mostly about pictures, I guess, and looking at it as like the bigger picture. I don't really see it as like a dependency.
Yeah, that makes sense. Yeah, it will be like a like higher level action of actually evicting the pods and using the eviction request. And that there might be other ways of like implementing the eviction, but yeah, we can track it here. I'm just saying like it's the eviction request is not like concerned about Node at this stage. It's just that it will be used by the other tools.
Yeah. No, I agree. Absolutely. Yeah, that makes sense. Okay. I think all right, if there's no more comments about the section, can continue.
So
I've got
sorry,
yes, go ahead,
just one last thing.
please.
So like, do we expect like to open like a new issue and a cap like as a result of this document, like for tracking the bigger like picture of the node lifecycle?
I think I think that would I think that would be good as a good goal to set as part of this document to reach that point. Yeah. I mean let's see. I would like to see if we can reach some alignment here. I think not like in this meeting, but like in the as part of a document, then absolutely I think that would be a good goal to set to have an issue for it. Yeah, so let's see. I think let's see. I think we need to, like you said, we need to get some requirements, and I think we need to build use cases, and then I think that would be nice to see happen. Right. Okay. I think we'll move on then. Okay, use cases. I left this here as everyone should have suggestion power. I left this here for everyone to make your case here. What is it that you'd like to see when we're talking about this problem of doing specialized lifecycle management, like when we're doing these node maintenances and we require a we're using this node and we're doing life cycling of it. what is it that what is it that you are doing? What is it that you're missing? So I think there's already been some that's been added here. It would be good for everyone, who's got a use case, please add it and we can review them. I think since there are some here, if people want to talk to them, we can do that. I can start with the first three since they're all related to GPU. What's interesting is that for all these three is like this is hardware, right? So we're tied to the node. There's no like there's no way to individually life cycle a GPU. So that means that we have to use like the node API to help us with the scheduling. So we do regular GPU maintenance. This is a pretty common thing people do, just like anything else in hardware. And so we need to drain nodes and then do maintenances on them. And then the other two are combinations of that, which you see a lot of where you have nodes with many GPUs on them, two or more. A lot of times I actually see people with eight, and that has its own set of problems where you might want to life cycle or do maintenance on one GPU, and that has a cost that could vary. Perhaps you're able to work on one GPU and not affect a node, but there's also cases where you want to do maintenance on one GPU, and that requires draining the entire node. So that has an interesting um, set of challenges. And then the last one, which I think I spoke of briefly previously, which is the multi-node GPU maintenance. Um, that one's really challenging, and I think it's already being explored even today on the scheduling side, just the gang scheduling side today in Kubernetes. We're already seeing some discussion about it. But there's also this is about the gang maintenance side, if you will, where now for scheduling pods or workloads as groups, well, how do we do maintenance as groups? Do we need to do maintenance as groups? Like, how do we need to look at these things when we're looking at GPUs as cross-node objects that can be cross-node compute that can be leveraged? So that has another set of challenges that would be interesting to talk about and would also require various amounts of node draining and coordination to occur to be successful. Okay, do we want to talk about the other ones? Like Lucy, do we have Lucy here?
Yeah, I'm here. I'm just
Hey Lucy.
no worries. Just got back from the hospital, so I may not be at my best, but absolutely, I have no issue quickly talking through this. So, I'm just reminding myself by scanning it myself. Okay, so within the technology stack we currently have at Uber, to take an example, there are many reasons why we might want to put a node into maintenance, and those can vary in priority. So there could be, for example, oh, I need to take this node into maintenance because at some point I would like to upgrade the kernel image on it. But on the other hand, there could be, I need to take this node into maintenance because the disk the disk performance is showing there's bad sectors. One of these is much more important than the other. Um, right now, we visualize that through like our own thing, and then we take that context priority and we combine that with, say, what impact is draining this node going to have on the application. So if I take this node away rather than this node, for example, I'm only going to have to move X databases rather than Y, or X stateful applications rather than Y. And that's all out of tree. And I never expect Kubernetes to actually have to make those very, very complex decisions. But what is in tree here, at least for me, is I want to be able to visualize that intent through Kubernetes itself, through node maintenance objects. And what I'm getting at here with this use case is node maintenance objects should not implicitly be expected to proceed to advance in any strict timeline. So like I could be waiting for node maintenance to be cleared to go through for days, even weeks on the extreme end. But yeah, happy to answer any questions on that. Just I might be a bit rough compared to normal.
Thanks, Lucy. I think so this means like you could set a node for maintenance, right? And that it may not happen for a really long time. So it is like a state where we it where it is like so you've got pending maintenance. Like it may happen, but it may not happen.
Exactly. And maybe I could, to give an example of what it should not be like, it shouldn't be like the eviction API where it's a point in time yes no decision. It should be like intent. It should be like, I would like this node to go into maintenance whenever it can. Might be might be in 5 minutes because it's going into maintenance for a really bad reason, or it might be a very long time.
And does that assume that like something is going to decide when that will occur? Something else
Yes,
will decide. Okay.
that assumes, and I'm guessing that thing would be out of tree and
And
would
now,
have some
yeah,
sort
that's
of
true.
ability to block or not block maintenance with its own conditions or something.
Go ahead, Philip. See your hand up.
Yeah, so I would like to react to two things. I will handle the second first. So like anything we design, like when we talk about like out of tree, like that we will have like other components like interacting with the API and doing things. Like there has to be like standard compliant like Kubernetes behavior behind the API. Like you can have like
Of course.
things like that can react with that, but we need to have like a standard Kubernetes way of like when you just have a Kubernetes cluster that it is like doing something or useful for something
When
in that scenario.
when I say out of tree, I just mean the decision matrix that could be infinitely complex. He want an example of this, but not applied to Node. An interceptor is out of tree.
Yeah, I
You
understand. Like, I
still sign
mean, like,
contract,
but
but yes,
even
the decision matrix is
I,
all
I,
is
I also wanted to react like to what Ryan like was saying, like that like other folks could implement it, but like we need to also like focus on the scenario where you just have a clean Kubernetes cluster. So like both of these are valid, but just mentioning it to keep it in mind. And yeah, and the second thing, like yeah, I think it's like as we saw in many cases, like it should be like possible to cancel the node maintenance. As you said, for example, you need to analyze like if you like if and when you want to go through with the maintenance. And I'm still not don't know like if the API review will pass the cancellation phase of the eviction request. So the eviction request is written in a way that it can be canceled. So it's basically ties also to the node maintenance. When you cancel the node maintenance and the eviction is going like is like in progress, that then you can actually revert that decision in some capacity. So we will see how the API review goes in that regard, and if we can support that. And regarding like the waiting time for the node maintenance, yeah, I saw like in a lot of like in your presentations and in other projects, like when doing node maintenance, like a lot of times there is this like simulation phase where you actually have to evaluate like what nodes you want to target and what workloads like basically to supply the logic of how you achieve it or like what will be the end goal of the node maintenance. So I'm wondering like if we could if we can like express that somehow, like the simulation, I mean in the node maintenance or the node lifecycle scenario, and even if it makes sense in the eviction request case.
I
Yeah, sorry, you are muted, Lucy.
Oh gosh, I just went off on a whole thing. Let's see how much of that I remember. Yeah, I think that sounds reasonable, especially the whole idea of simulation. And to me, um, I think the intent itself can be useful there because, like, with intent, we can simulate, in theory, what the result of removing a node looks like, and then decide whether it goes forward or not. But it's definitely like so the intent part and the modeling part definitely lands with us. I would say but I would be very cautious about us not getting involved in doing the simulating ourselves because it's just there's too many things to pull on. I don't think there's a good universal solution that like is good enough to end up as a K standard. But there definitely is for modeling it, in my view. Just yeah, I'm just trying to draw boundary lines.
I wonder if like the maybe a way to say it is that the eviction request is like an intent to drain, and then we need something that is an intent to do maintenance. So like a separate API that does that and feel it.
Yeah, I would not like overburden the eviction request API. Just I would like to focus on the pod itself. But I mean, it can interact like, or we can interact with the eviction request somehow. So I agree, like if Lucy, like the simulation part is very domain specific. It's just like that we might want to enable that from like the Kubernetes perspective. And I think like two ways of doing that would be, so first one is maybe we could like have a special condition or a state like on the node or maintenance that we are in a simulation phase. And the second part is like because like we are designing the API in such a way that like the interceptors should have like intimate knowledge about the pod and the application and what like like where like it wants the application like to see like or what it should be doing. So like as of today, like the eviction request is quite extensible. So I suppose like we could add like some simulation kind of or type of eviction request that maybe we could just trigger, not like with an intent to evict, but with an intent to actually say like we are thinking about evicting this pod, but maybe we would like to get more information from like all the interceptors, and then once we compute that, we might trigger the eviction round again. Like this is just like just a
Yeah.
thought.
If I'm spitballing here, and this really is just spitballing, not endorsement, you could do that through some sort of well-known interceptor that we then expect in that if you want to support that in your interceptor, then it's kind of on you. My only concern with this is whenever I think back to API objects where a single property dramatically changes the behavior, I think of service API and how that went. So I just yeah, that's my only hesitation here, really, if that makes sense. Like it is sometimes strange when an API object behaves very differently based on a property in it.
Yeah, I'm just thinking a lot. So, like for sure, we will not be introducing this behavior in alpha or beta, I suppose. So far it is like pretty straightforward, the API, but I feel like as we saw before, that there are like multiple termination mechanisms in Kubernetes today, and like the application is not safe in like all of these or the other ones except like the classic eviction. So like I'm expecting that we might add like other types, for example, for the taint eviction or for the preemption, uh, like some kind of different eviction mechanisms. So we can actually like use these interceptors in other scenarios, but maybe they will be like less graceful than like the eviction itself.
Yeah, that makes sense. But yeah, I think I could easily see organically users effectively ended up using conditions to signal, especially since I know we've had like a bit of back and forth about should there be a standardized way to communicate between evictors and interceptors. But as I said in the Slack thread, I think it's too early for us to do a good job if we even try to set an opinion here yet.
Yeah, I think like with all of it, we are designing like we should aim like for it and the extensibility. So like we cannot capture all the use cases or like predict the future here. So let's try like to make something which makes sense for most, and then like expand on what we have later.
Agreed. Oh shit, I couldn't. Oh, there we are. Also, because every time we add feature creep, I don't want to hold up the release train of this for like forever. You know, I've seen that before as well.
Yeah. Ryan, sorry for going to the eviction request API. Like we
No, it's
can.
okay. We gotta. I think. Well, and this is the thing. Right? This is why I think we're always going. There, it's hard to like not because we're like these things are going. Like you can make arguments how these things are very tied together in some ways. Like you could say, like if we want to, like where do we want to have this pending state? I think yeah, like a pending maintenance state. Like it could be exist in a bunch of different places, and we can see use cases for them. So that's why I like having like I can understand like where we want to talk about these things because I think we want to decide where we want to place them. Like, do we want to place this in an eviction API, in a node API, in a condition, on all of them? I don't know. Like I think so. I think it's good to think about like how it crosses like a bunch of these things. So that's fine. I think we'll have probably more discussions like this to come. Okay, let's go to the next one. This is from JP. Do we have JP today? Okay, I can read this, I guess. So addition to deferred maintenance, So not only want to declare intent, also want to follow the progress. So this would allow any administrator of a node to see how long the process has been running. Okay, so I guess the way I take this is that we have some sort of state that's saying that there's we had intent, and then some state that's saying that we are um in progress, and that there should be a way to see that either an API or something that's we can see is actively progressing or moving us in the direction that we will reach a completion or moving to the next state. Okay, I don't these are my interpretations of this. If anyone else would like to comment, please just jump in. Scheduled maintenance as of a subset of nodes according to a maximum budget, also JP. The reboot case is simple. Something marks n nodes as a need of reboot. To avoid main disruptions in parallel, we want to declare a maximum number of m nodes allowed to be in maintenance at a certain point in time amongst n nodes in need of reboot. M is less than m. Go ahead, Lucy.
I worry that having the API just be based on n nodes of m, it falls into the same trap that pod disruption budget fell into, where part of the reason we're building eviction requests is because PDBs are not expressive enough for the complexity of applications, especially when nodes are very different from each other. So I just want to push back on the m of n expressioning. I know it's great for like entry low barrier of entry, but there's a reason we're building eviction request, and it's because the eviction API, which uses m of n for pods, is having issues.
Yeah, I was having similar thoughts here because I kind of looked ahead to the next one because um I thought of a similar kind of thing where this does read a little bit like pod disruption budgets, like node disruption budgets or something. And I think what we want is like this kind of thing. I don't know. I'm a little hesitant to maybe like to say like we want to say, okay, this amount of nodes can be disruptible. It's almost like we can define this in a different way. Like it's as if there has to be a native Kubernetes way to say like here's the maximum number of nodes that you can disrupt right now, right? Because then we can always block and we can run into the same problems that we do today with PDBs.
Exactly.
Go ahead, Philip.
Yeah, I think I don't mind like tracking this, but like as you both said, like we should not go into the more advanced features because like it has like major problems, and we also don't have capacity to work on everything. So yeah, let's try like to find like the common denominator for like all the problems, and let's try to like solve on the more like simple things, or like I don't mean simple like in a logic sense, but the things that like that we have an ability to solve like for the most of the people. And I mean, there is also like a lot of other solutions that have like basically this logic, like what kind of nodes to reboot when, and like we are not trying to replace like all the like drain solutions existing today. Like we are trying to like supplement like some of their like um like some of the like API and some of their logic that they can reuse. But yeah, let's be like aware that these advanced features they might come later, but not now.
So maybe a way we can take these use cases is that the solution we want to have can support creating or support having these features. Like I could see like if we, for example, um, if we had something on the node that were to tell us that we intend to do maintenance, like Lucy was talking about. Um, in theory, like JP could write, or anyone could write an API that were to say, oh, we only want a maximum number of these things to go into maintenance, right? Like I think so. I guess the way I'd say this is that um, I don't think we need to support like an API that does exactly this. Like so I think we want to have something that would allow for that API to exist or that feature to exist if we ever wanted to, if we ever wanted to have it.
Yeah, that's fair. I mean, if it's so unexpressible that you can't even do M of n, then what the heck, guys, did we do? At least this is my view. But the part for me that's important is this is just an expression that we don't care. We're not going. I do not want this to appear as part of our API contract, or our modeling.
Yeah, I agree with that, Lucy.
Yeah, I guess it might help like if we like introduce like a special section here or a tab, like where we say advanced or use cases that we plan to enable, like by our efforts.
Yeah, I'm trying to think how we want to communicate this. So there's
Because
not any
if
confusion.
if somebody comes and reads through all these use cases and they
Right.
expect like that we like adhere to these or implement these, so it might make sense at least visually to split them somehow.
Yeah, I'm thinking. I mean, and the other thing I can think of is like eventually turn this around into requirements, and then the requirements clearly state, what the intent is, and then and then that sort of maybe clears up any of the uncertainty when reading this. There's another hand. Go ahead. Who is the hand first? Is it Lucy or Darshan?
It
Mine
was
is up
Lucy.
by mistake.
Go ahead. I couldn't hear what was said there.
I said mine's up by mistake. Please go ahead, Darshan.
Yeah, on the M of n, I think it will also depend on other things like node groups. For example, certain nodes will have GPUs, and then you don't want to have every node in that node group to be down at the same time. So I think that the M of n is also like not the full thing. We will need additional work if it's implemented also. We can't just have M of n of like normal. There are M nodes, and then you just want n out of them to be in maintenance. Just wanted to add that.
Yeah, no, that's a good point. I mean, so there you go. There's the complexity of it, right? It's that's very complicated. Now, how do we support something? So I think there's a lot of complexity here, and I think that's sort of the idea is that if we can come up with I think, and we can come up with sort of a solution that enables someone to solve the problem for themselves, and if maybe if we're lucky enough for the overall community, that would be tremendous. I think that would be a great measurement of success. But I don't think we need, at least in this document, in our design, I don't think we're trying to solve specifically this problem, M of N.
I
So
agree.
maybe like, so maybe we need to, I don't know how we want to do it. I don't know the best way to do this, but I mean, the way I'm leaning is that like if we can come up with the requirements, that would at least narrow this down. I feel like to make it very clear, like we're not solving that problem. We're just trying to enable someone to eventually solve it if they really want to solve it that way. Go ahead, another hand, Darsan.
Yeah, I think the problem that is being mentioned by JP is that when there is a kernel update and then every node basically gets the same kernel update and then it wants to reboot at the same time, he's just trying to like time space it so that it doesn't happen at the same time. That is the problem he's trying to address, and I just want to give like a context of what he's trying to say.
Yeah, that makes sense. And I think, and I think also like what we're saying is that there are probably multiple approaches to solving that problem. And I think because there are multiple approaches, I don't think like the goal of this document or this, I guess, the goal of this document would not be to solve that problem, would just be to enable someone to solve it in whatever way that, makes sense for them. So I think that which is what we need to keep in mind. I think I don't know. I don't know the best way to do this, but I think to me, if a requirement stating that, we need a state that is going to enable someone to do that, if we need to be very explicit, I think that would at least give us, I think that would at least satisfy us, in my opinion. Okay, I feel like this covers a few. Go ahead, Philip.
Yeah, I just want to finish this topic about the M of n. Yeah, so to me this seems more like the node maintenance scenario. So I think like we need to make a clear distinction, like that we are mostly like looking at like the life cycle of like this, defining a life cycle of a single node. Like I guess we can even like think or talk about like the like multiple nodes, but like it has to come from the requirements. And for example, the node maintenance also like as of today supports like multiple nodes of like writing a single object for a node maintenance, but this did not come from the requirements. Like we actually just like experimented with the API and talk about it and said, oh, it might be interesting to edit there. And we edit like a node selector, and the node maintenance supports like multiple nodes, but like we found like a couple of problems with that. So for example, like expressing the status for like multiple nodes, you are running into the limitations of the API. And so like we started doing it more like complicated than we had to. And yeah, it's better to start simple and like let's try to solve like the requirements like for all the like the common thing that we have to solve. And this goes even for the lifecycle management, I suppose. Like if we have like if everybody is on board like solving it for multiple nodes, like we can do that, but yeah, there has to be an interest first.
Okay, I feel like we're aligned. I think we'll need to get this into requirement. I think there's probably one or two requirements from these three. I think we just kind of went through. They seem like they'll fit into a requirement. So I wrote down a few notes, and I can take that into a requirement. Okay, let's continue. I think we're on the last one from JP. This is process reboot. So this one is when we've drained the node, we want to trigger a reboot. The reboot is very impactful. We do not want to reboot if something else is happening on the node. We can't know, excuse me, what's happening on the daemon set because they aren't drained. So we ask ourselves to have their own reboot. So we ask ourselves to have reboot scripts based on everyone's needs. This is a hack. Fixing that by defining a consistent interface is better. So unlike scheduling state of a node with maintenance, and then curd, we want core and drain the node before we reboot, but after maintenance, the node should be resumed in the previous state. So curd stores the schedulable info of the node to restore it after the reboot. This will make sure corded node state stays corded. I think there is a few things here. So the last one was interesting. This is a so we're sort of this the second one here is like where if I could maybe see a few things from this. This is like we did we did maintenance and we don't want it to return after maintenance. We want to be in this unschedulable state after reboot. There's lots of reasons for that. I mean, you might want to do validation, for example, or maybe you want to do more maintenance because it didn't work, or you have other ones queued up. I can see a few out of this one. Yeah, go ahead, Philip.
Yeah, so I think we sort of established that like the spec schedulable field is like problematic, that it's like an only binary choice, and lots of tools are using it inconsistently, and like who flips it when and how like changes the meaning of the other tools. So like there was like presentations of it, like taints are usually better in this scenario, but taints like are also like not like great for this, like because you need to actually know like what tolerations and what kind of pods like should be on the node and should not be, and you have to also play with the tolerations. So it's also kind of difficult to like synchronize across like multiple applications and like environments. So I think this is like still an open question, the schedulability, and like what he mentions about daemon sets is also true. Like there are also like issues of like draining daemon sets, and they have their own like behavior of like when like what kind of daemon sets should be running on each node. So like we would like to include the daemon sets in the APIs or like in the standard behavior of the drain and the node lifecycle, because they belong to the node and are like a usually high level or privileged applications that should be running in most of the cases, but they are also involved in the scheduling.
Yeah, this one's a tricky one. I think this is where kind of what you're getting at is that like the daemon sets and the pods on the node, like what we're trying to do is like the spirit of this is what I'm reading is that we need to define some sort of drain state like before we do reboot because it's impactful. So we need to know when we're drained. And kind of what you're talking about is that how is it is extremely difficult to define when something is drained. There's like a lot of complexity there. And yeah, I agree. I mean, that's really difficult. I this one I this is where like I think we have to rely on the user. I don't know. I mean, he says that so his perspective is that we ask our users if they have their own reboot scripts based on their needs, and this is in his opinion this is a hack. I don't know. See, I don't know if I agree because this one I have a hard time with. I don't know how we will ever be able to define when something is drained. And I feel like the user has the best chance. I mean, I feel like that's all we can offer in this case is a chance to be able to define what drain is. But I don't know if there's some sort of universal agreement about what drained is. I don't think we'll ever be able to come up with that.
Why do you think we will not be able to?
Why do I think we won't be able to?
Yeah.
Is that what you said? Um, because I think there's so much nuance. Like, so here's where think it's tricky is that if you like, let's say you have daemon sets in the node, right? And let's say there's device plugins, and you've drained your workloads, and there's some daemon sets. There's the device plugins that are there. Is the node really drained? I mean, I would argue that it is. I don't. My workloads are gone. Nothing is going to use whatever the device plugin would be, the services the device plugin would be providing. I don't even need to drain the device plugin anymore. I can do maintenance on this node. So like all of those nuances, like I don't, there could be any number of pods that could still be on the node and I could consider it drained. But
Yeah, I understand like there might be nuances, but look, for example, at like the graceful node shutdown. So they have a problem of actually going to GA with this feature, and would be really happy to use like what we do in this working group to also like GA the graceful node shutdown. And basically, graceful node shutdown means like they get a signal from the node that it's going down, and they like try to terminate all the workloads in like the order like it is described in the graceful node shutdown config. And So basically they need to have like the sequence of actions defined, like what has to happen before the node is drained, and the node is shutting down for sure. So like when they get to the point they feel like that the node is like drained, like they will shut down the node. So like this is only like one use case of the node lifecycle and the maintenance, but I feel like we should be aiming like for like have some like, declaration of the future drain of the node that like people can like double check or check like what are the steps of actions that should happen before like we can achieve like the like full drain.
That makes sense. What I'm saying is is that you can define drain in many different ways, and that is what I guess I'm saying is like that there isn't just one definition of drain. That there's a lot of definitions of drain, and then we could absolutely define like drained means that the node can start its maintenance. We can define it like at least that's my perspective is that we could define drained as like this thing is ready for maintenance, not so define it as that, but and not define it as there are no pods on the node or there's no, I don't know, like I come up with there's no storage on the node, there's no PVs, there's no, I don't know, like what you want to come up with as a definition. Like it's slightly different, right? It just means it's ready for maintenance regardless of what's there. Because I guess what I get worried about is that if we were to try and define like one state, like the node is drained, like how I feel like we can get into trouble where like there's so many ways for us to get blocked from ever reaching that state. And then we're kind of back in like the the PDB world.
Yeah, in that case, like it helps a lot, like if you have observability. So maybe if you have some kind hooks or statuses, so that you can actually see like how the drain progresses and what are all the actions needed and how are they actually evolving over the drain over the time the drain is happening.
Yeah,
Yeah, I mean we don't
that
have
makes
to
sense to me.
we don't have to solve it right now and just like um yeah, and just reacting to like what is the direction of the API and like what we like want to solve, what should we solve, and like what basically what's the framework of we are operating in.
Yeah, no, that's a good discussion. We should have this discussion. I think. I mean, we probably will have it down here. I mean, we're not far away from it. I think, like we should come up with our definition. Like, and the reason, like, and just like as a, I think just as a preface to this is the no condition is like, right? These are states, right? These are just the ways that we can talk about it. Like, I think the use cases that we want to have a way to do drain. I just called these no conditions. We can call them whatever. But you're like, what is the definition of draining? And then what's like the definition of like when something is drained? You know, like we should. Those are really good debates that we should come up with. I think that's really important for like graceful node shutdown, like you said, and for like this case that JP is highlighting. I think there's, I mean, really all of these drain cases. I think it's really important. We'll need to come up with that definition. So I think there's a requirement here though. I think there's a requirement here though, like which is that we need to have some sort of like what I'm taking away is that we need to have some sort of drain state. Like when way to define when something is drained. That was my takeaway from this.
Yeah, plus like all the like the schedulability of things and like the scheduling aspect is also important. And yeah, we need to also have like collaboration with the SIG scheduling, once we introduce like the drain specific features, because I feel like it will affect scheduling a lot, and we need to have discussions there.
Yeah, absolutely. Okay, this is good. We got through the use cases. This is great. So I think we got 2 minutes left. So we'll go to your topics in just a second, Philip. I think if we can next time, if there's no topics, we can continue going through this. And then so I'll just ask for everyone if you've got any ideas for a condition or a state that you think you'd like to capture, let's have it here and then let's have the debate about the description and the definition of it and see if we can define it and see how it fits these use cases. And I'll come back and take some of these use cases and come up with some requirements for this. And then this should match what we're talking about here in this section. Go ahead, Philip.
Yeah, I would like to add to this that it would also be great, like if we could define like transitions of these like states or conditions, like for your specific use cases. Like doesn't mean we will use these, but it would be great to like have an idea like what people would like to see in like in their like API or in their life cycle, node life cycle.
This would be like when you say that, this would be like a transitioning. Oh, okay. Actually, I have these as conditions. So they would just transition back from one another. Do you mean like how would you want like the order you'd want to see these things used? Is that what you mean?
Yeah, so for example, like we have today, like that maybe you have cordon and drain, like they go after each other, but people might have like their specific scenarios, like some pre-checks or the simulations or like anything you wish like there to be in your like node life cycle, like that might not be useful for everybody, but like your use case, it would be nice to like actually have a reference to what people would like to see.
Okay. I'm gonna have to think about how we can express that. Yeah, that would be good. Let's see. Okay. All right. I think we're a minute over, Philip. So I'm sorry. I don't know if we're gonna be able to get to this one unless you can do it really, really quickly.
Yeah, I will just in a couple of seconds. Yeah, it's just an update. I'm like we can go over the cap like in the future if you want to. Basically the cap is ready for review, so I have asked a couple of folks to review this, but like anybody is welcome to review it, so it will have like an impact for lots of users. So feel free to drop any comment you want you would like to see or what you are missing. And like since the last version of the API, I added like a couple of fields to the spec to be to have like it more structured. And yeah, so like we don't have that much time until the cap freeze is done. So let's see like the reviewers availability and then also ask people for the API reviews. Like I know like Joel is on a vacation today, so I will ask him next week for also another API review, and hopefully we can get this moving forward. But yeah, there is not that much time, so don't get your hopes that high up. Thank you.
Awesome. All right. Thank you, everybody.
Have a good one.
Have a good one.
Bye.
Am I going to see any Hugh
Bye.
Coupon, by the way?
Uh,
Too late. They've all
yeah.
dropped.
Let's see, are you still